In this video, you'll see me working with a group of pre-service science educators in planning for a 3-week unit of instruction. This unit explores how climate change is now affecting ecosystems in the Antarctic region of the world. If we think about the 4 sets of core practices, we're now in the upper right-hand quadrant. This kind of planning involves 3 practices that build upon one another. The first practice is unpacking and prioritizing the science ideas in the curriculum and the standards. The second practice is identifying an anchoring phenomenon and developing a causal explanation for it. The third practice uses this causal explanation together with the standards to develop a sequence of learning activities for students. I start the unpacking practice with my novice teachers, making them aware that they may be handed many different kinds of curriculum resources in schools where they will work. Sometimes this may be little more than a promising activity for students. The video here only shows snippets of this practice. In the real world, it takes more time and deliberation with colleagues to do this work.
The activity that we're going to do today, and it's really a unit that we're going to model over the next few days, is an example of what happens if you just get handed nothing more than an activity like this. So in front of you, you have, this would be for high school sophomores studying biology, and your cooperating teacher says this, we want you to teach something about ecological systems. And I found this really good activity. Some teachers have done it. They swear by it, that it really gets kids engaged. So it may be a good place to start, but all you have is an activity. So what I want you to do is, out on the table in front of you, you always have to have whatever resources you have, which in this case is just an activity. You also have to have your standards out in front of you, and I've copied the standards, the next generation science standards for ecosystems. This is all there is. You may think there's 3 or 4 pages and I've just picked one. This is the only page they have. Let me give you a little background on what this activity is, because that's like an advanced organizer. So this is an activity about the changing ecosystem in Antarctica. And it all starts with the increase in air temperature and that meteorological cycle that I talked about, in which air temperatures are going up, sea ice is becoming more sparse, and there's a lot of organisms that depend on sea ice. Some of them depend on it directly, some depend on it indirectly. What do you think are some of the big science ideas that are either in here or that could be in here, if we tease them out a little bit? Rick?
I guess using representations of data to construct like an explanation from it would be my first one, which connects with the HSLS2-2, using mathematical representations to support and revise. You guys agree?
I think the standard HSLS2-4, use mathematical representations to support clinical cycling matter flow energy and order ecosystem. I mean, if you have these 5 specialists and they all do some kind of graphical analysis, I think that they'll see a trend in the data.
I think that if we're going to look at the standards, talk about it that way, to me 2-6 jumps out as being overarching. But
Yeah.
the point of this activity is I understand it.
I agree.
LS2A.
Yeah, 7 is good too. That's from flipping through the activity and then browsing these standards. That's where I see the most alignment.
Okay. Any others of these that could be potentially addressable using either this activity or taking this activity and extending parts of it?
It's number 7, I agree with Graham. If you maybe added a little bit more on this about why the sea ice is melting because of humans, that would definitely fit into 7.
At this point in the discussion, one of my novice teachers asks a very direct question. one that she eventually answers herself. And her answer gives me confidence that she and the others are making sense out of this planning practice.
I have a weird question. Why are we doing this thing?
It's, what we're doing this for is because it's authentic to what you guys will experience. You get little or nothing in the way of curriculum, just get an activity. However, if it's a decent activity, what you can do is some of the things that some of you have already mentioned, and that is not just treat it as a, this is treated as a, right now, I think is like a 2 or 3 class period activity.
This could be like deep tech activity for sure.
It can be, what did you say, Molly?
It could be the entire unit.
How could this be the entire unit?
Well, if you supplement appropriately with maybe the gaps we were talking about, like with the energy pyramid and the biomass discussion and stuff like that. Like this could be an anchoring event type unit that they work on in the entire unit.
No, you answered your own question. You're exactly right. If you're resourceful and you've got a decent kernel of an activity that has some complexity to it, it's possible to take pieces of ideas in here and blow them out further than they normally would be in here.
As we close our discussion of the first practice, which is unpacking the curriculum and the standards, I caution my novice teachers not to treat the standards as a checkoff list. This would result in disjointed learning experiences for students. Rather, we want just 2 or 3 carefully selected standards to be explored by students in the context of an anchoring event or puzzling phenomenon.
Well, I worry that some teachers will think that their job is to just check these off one by one. I'm going to do an activity that meets HSLS2-1. I'm going to design 4 days of activity and address that one. Then I'm going to address another 4 days of activity around the next one, and then the next one. But what I'm trying to help you understand is that you don't want to approach the next gen standards as though they're a checkoff list. What you want to do is think about having a very rich anchoring and relatively complex event that you want kids to develop both a model for and an explanation for. And then once you think about what that could be, then you look at these standards and say, how can these standards be built into that effort to explain something that's really important very deeply? How can these be integrated into that?
For each anchoring event that we have, we want 2 to 4 standards.
Yep.
Okay.
Yep. And you just got to go back and forth. Sometimes you've got to switch which standards you're going to address, and other times you're going to switch what activities you're doing in the unit. It's a balance between the activities and the standards. You go back and forth and back and forth.
Following the unpacking of curriculum and standards is the practice of selecting or generating an anchoring phenomenon. This event or process should be complex enough to engage students for 2 to 3 weeks. It should require that students coordinate many different science ideas in their final explanation. It should be situated in a particular context, the details of which have to be taken into account in the final explanation. In our methods class, we decided that the decline of the Adelie penguins was an obvious choice as an anchoring phenomenon. We then developed an extended explanation, which included climate change effects and ecosystem relationships. It ended up being an energy story. We decided to have our students treat the climate as a dynamic model itself, with components that include the sun's radiation, the conditions of our atmosphere, the ocean's ability to retain heat, and the surprising role that sea ice plays in the biotic parts of the Antarctic ecosystem. We introduced the idea of energy as it moves from producers to different consumers. We added the idea of how organisms compete for valued resources, how consumers expend precious energy as they forage for food, and how changing environmental conditions give advantages to certain species. The final planning practice involves taking your causal explanation, identifying the key science ideas in it, and then using these to arrange a sequence of activities for your students. In this segment of video, I show 3 ways to think about developing this sequence.
But you can think in terms of the first third of your unit. I've got them in green lines up there. And there's 3 ways you can think about this. One is that you can think about allowing kids to engage with more familiar ideas to them early, perhaps ideas that are more concrete, as opposed to later in the unit where you might transition to more abstract ideas or ideas that are unfamiliar to kids. A second way you can judge what comes early, middle, and late is ideas that are prerequisites for other ideas. In this explanation about the penguin decline, there are some things that must precede others, otherwise they won't make any sense. The third criteria that you can use is there is a causal story here that it sometimes has a beginning, a middle, and an end. It starts with something. And sometimes there's ideas in the causal story that don't come along until the very end. So you can use any one of these 3 criteria that you want to place what you think comes in the first third, middle third, and final third of this unit.
We end this video by sharing the reasoning of our beginning teachers as they deliberate about how to sequence ideas for this unit of instruction.
Should we brainstorm all the different topics and then decide what the overall narrative looks like? And are we going from laying a foundation and becoming more complex, or are we going from concrete and familiar to more abstract, maybe?
So what I would do is I would start and end with food webs. So I would start with the Adeli's food web up here, but not talk to them about like what's being knocked out in terms of that.
Can they understand the impact of climate change on this system, this food system, that's affecting the Adelis and leading them towards extinction, if they don't understand the connections of the food system?
Okay, well, we were looking at this sheet to start. And we actually just went through at the end again and kind of talked about which one we think we followed, and we really went with the idea that some things are prerequisites to other things, and we also looked at maybe what was less abstract to more abstract. Yeah, sure.
So these are your ideas on the left?
Yeah, over here and then over here.
So what are the ideas on the left?
So we actually started on the right, which was like different ideas about why the Adelis are disappearing. And then this is what this became, trying to like organize all the information. And I think one of the things that we are currently grappling with is that they're all really interconnected and it's hard to split them. So hooray, that's probably the idea. And that our final like thought, well, we were also like deciding if maybe this is a beginning thought, that like it's this 3 degrees that is the 3 degrees that is affecting all of everything else.
What do you mean 3 degrees?
3 degrees in temperature, that is right?
Yeah. Is that all it takes?
Apparently so.
For all this to happen?
For all of this to happen.
As we look back over all 3 planning practices, we hope that 2 messages are clear. One is that a deep knowledge of science subject matter is important. The other is that planning for ambitious teaching is an intentional process, ensuring that learners encounter important science ideas in the context of problem solving about complex events in the natural world.
Once we start looking at the food chain,